We have two aspects. I'm not going to go through the video because I think everyone has seen it, and I'm going to talk about the actual stuff here. If you guys are interested in watching the video, just you'll find it in YouTube. I don't know if Ian Hooper is here. I saw his.
He's online.
Yeah, that's it. I sent out a notification last minute to the team to join the talk. So yeah, there are two aspects in the project. One is the semantic knowledge base, and the other one is the natural language chatbot. That's what the title says. And the name of the team is Semantic, and we had 10 colleagues in the team, and they're all from all over the world. Here you see a breakdown of the different geos the people are from, and the different divisions that the team members are from. Some of them were from India and Singapore, so we had a 12-hour time difference. And so they started working the day before us, so we had to.
Yeah, you have more time.
Yeah, that's part of the rule, by the way. Ask Karine about it.
She did.
No, that was part of the rule.
Clever use of game mechanics.
But no, we had to, we didn't have, it's not like a 6-month project where you can wait for the next day for the other person to reply to email. You have to figure out a way so that nothing goes wrong when the email comes to you on the hack day. So everything had to be properly fine-tuned, and the brainstorming meeting before the hackathon was also, some people had to stay up 1 or 2 in the morning to do that. We reached the semi-final, so that's the top 12 out of 170 plus teams according to the email that Karine sent out. That was a big achievement. So the problem statement is very simple. There's too much knowledge at Autodesk, and not everyone or most people don't know how to get to the answer or knowledge that they're looking for, either a domain-related knowledge or product-specific or any other type of knowledge. So when I say unstructured, it doesn't mean the documentations themselves are unstructured. It's more of it's not machine readable. It's not like XML or any other format that you can just start reading using some kind of a code. It's human readable. It's structured for human understanding, but not for machine. So it's not easy to find and locate information, and sometimes you don't even know what to search for, even if you know the concept. And the other problem is, even if you're an expert in one product or domain, and you need to search for something in a different domain, you don't know the actual naming conventions or the concepts that you need to search for in the other domain. So it makes it hard to do certain things. So some of the problem areas that I discovered when talking with the team members and other people. One of them is improving render quality. It's not easy to figure it out in Max or probably any other modeling software because there are so many parameters and options to play with. And the finite element analysis, you need to have expert domain knowledge and physics modeling and certain other areas to be able to do that. Even if you know how to do modeling, you need a good understanding of how the physical world works. So these are problem statements that were provided by, one of them was from Ian Hooper, another one was from Yoon-Min Chiang from the Dreamcatcher team in Toronto, research team. So these are from real domain experts who encounter these kind of problems in their life. And it takes a lot of time to figure the answers to these problems by just looking up in documentation or forums or things like that. So this is the problem that we're trying to solve. And the solution we're proposing is the knowledge as a service. But more specifically, we want to use some kind of knowledge store. We don't want to use a database because database doesn't have the semantic information of what you're looking for. So we want to use a semantic knowledge base, and semantic web technology is the standard from W3C. A lot of companies like Google and Microsoft are using it. Like mentioned at the bottom, like Google's Knowledge Graph, Knowledge Vault, and Microsoft's Bing Satori engine, they're all based on semantic web standards. So it's pretty widely used. And we also want to use natural language interface instead of having to learn a query language or some kind of command to be able to search the knowledge base. Outlining here some of the advantages of using semantic knowledge base, but I don't want to go through them right now. It will take a bit of time. But there are certain advantages of using knowledge base rather than just regular database. One of them is that you get granular knowledge rather than having a database with an API. You don't have granular access to every problem, every statement or information. It's all based on what the API gives you. That you're limited to. But in the semantic knowledge base, you have granular access to the knowledge. It's just some definitions. These are some terminologies that the semantic web technology uses. RDF is the framework semantic web is based on. OWL is the ontology language. And Sparkle is the query language that looks very similar to SQL, but it's quite different. It's based on, the whole semantic web technology is based on a triple store. So at the bottom, you see every knowledge is stored as a triple, as a subject, predicate, and object. You can think of it as a normal database table with just 3 columns. And so every knowledge will be stored as information in 3 columns in a regular database if you were to use an analogy. And at the bottom, I'm giving an example of a triple, like raw, is Autodesk raw. FOAF is one of the common ontologies. The name, Rob's real name is Robertine. So this is a triple, subject, predicate, object. This is from the web. This is actually, on the web, this is live, interactive. So you can go to each one of these little circles. DBpedia at the center is Wikipedia, semantic Wikipedia. So, and it has and the triples that I showed, subject, predicate, object, it has 9 billion triples in DBpedia as of, I think, a few months ago. So 9 billion, each triple is a fact, a factual statement. So 9 billion facts extracted automatically from Wikipedia. And they're all linked together with each other. So you can, and each one of these was independently developed. So you have DBpedia at the center, which is Wikipedia, and then you have somewhere like the medical community, genetic ontology, pharmaceuticals. They all can be linked to each other, and the whole concept is called linked open data. There's some color coding here, so you see life sciences, geography, government, and all sorts of other things. And when you click one of these, it goes to actually takes it to the real ontology page, so you can link your own system into one of them. So they have all the information is there open in the ontology page of each of these. So this here is going to be a bit technical. This is what we have now, unstructured data. As I said, it's not unstructured for humans to understand, but it's unstructured for machines to understand. So we have documentation of forums and blogs and thousands of them for all sorts of Autodesk products. We want to curate them somehow. For the demo, I manually did a very small, tiny part of it using a software called Prodigy as a desktop interface. There are other ways to do that, algorithmic. Text to onto active media, these are some open source projects that exist out there. I didn't have a chance to really test the source code, but I had a chance to test the interface. So they can actually read regular text and extract information into an ontology. The last option is RDF triple extraction, which is hard manual writing the algorithm yourself using Java Gate, or OpenIntelligence, I think it's a Java platform as well. And some people were able to achieve extract triples out of unstructured data using that. So we go from unstructured data some way, algorithmically or manually or any other way. We want to create a semantic knowledge base. And it's not going to be just one knowledge base. It's going to be a whole bunch of them depending on the need, either depending on the product or the domain of interest. And moreover, it can also be connected, linked to DBpedia, for example, or Google's Knowledge Graph, which have an open API. So this is the back end, more or less, and a big picture overview of how we go from unstructured data to a semantic knowledge base. And it will have an interface to the front end. This is not the front end, this is just the interface that will do a bunch of processing, and the connection from that interface to the knowledge base is the query language for semantic web, which is Sparkle. And on the front end, the demo that we did for the hackathon, we were using a chatbot. We did not integrate it into any product, but that was the sort of the goal initially. And Ian Hooper and some of the other colleagues are interested in doing that for Mac. My interest was to use put it in a forum, for example. Other people have other ideas about how to use that chatbot. Some of the other use cases could be you don't even have to use a chatbot, you can just talk to Amazon Echo. It's a device that's available in the US, but not here yet. Some of the other use cases could be data visualization. You don't even have to do any speech translation. You get a picture of how different components of products or services are connected together. If the information is in the knowledge base, you can dynamically search for, if you wanted to know how the Forge platform works, how different components connect together, that could be one use case. So Forge platform, for example, developers can also use their own query using Sparkle or some other form, instead of using natural language to query the knowledge base directly as well through the platform, for example. The other thing is Cortana Intelligence Suite. This is the local Microsoft 10 Cortana I'm talking about here. This is something that if we want to integrate our bot into a product like Mac, we want to leverage the Cortana or some kind of machine learning for the bot to learn about the user's context and the need, instead of just being a random bot that the user talks to. So it will learn over time what the knowledge level of the user and the past history and the experience of the user, and provide answers based on the workflow and the history of the user. So that's something that can be leveraged. And finally, this NLP service. It's a web service coming from, it could come from anything actually. I tested IBM Watson, but I'm using my Cortana web service for natural language processing. There's Facebook's Wheat AI. I'm not sure if it is open, if they have an open API. There's Amazon Echo for the Echo device. So the flow that takes place, the user types in a natural language, asks a question to the bot. It goes to some pin interface, which doesn't do much right now. It sends it over to the Microsoft Cortana web service for natural language parsing. The parsed response comes back from Cortana with intents and entities and context. And based on that, we are using a Sparkle query to query the knowledge base. In the middle layer, the conversion from that natural language to intents and entities and then to Sparkle, that will have to be dynamic at some point. Right now, it's a bunch of if-else statements. We're just checking what intent the question has, and then we're creating a Sparkle query. But the goal is to have this workflow, natural language to natural language processing, to a Sparkle query, to the semantic knowledge base, coming back to the result set, and the natural language generation, and then to natural language. So some parts of it are working because of the NLP services we're using, and some parts of it are a bit like generating this Sparkle query is hard-coded. The goal is to have that whole thing dynamically doing algorithmically instead of having any hard-coded part in it, which is a big challenge. One of the biggest challenges is that no single service provides both NLP and NLG. Like Watson doesn't do NLG, Microsoft Cortana doesn't do NLG. They do NLP. They take your language and they break it up. They don't take broken up stuff and create a sentence for you. That's a completely different service. We have to figure out who does that best. There are things, open source stuff out there. Actually, like in the orange thing in the middle, in the interface, you see Auto Sparkle, Log QA. These are some of the open source projects that I looked into. They actually do some sort of that. So they take natural language and they generate dynamic sparkle query and regenerate responses. But I didn't have a chance to actually integrate them.
So I have a question, Mehdi.
Yeah.
So do you usually have NLP and NLG handled by one component, because it's relatively the same thing but different directions, right? Or is it usually it's two different components?
Well, ideally we should find something that has one, but so far I didn't find anything that does NLG to a good extent. If IBM Watson is not doing it and Microsoft and Google are not doing it, then I guess it's hard. So they are all doing NLP. Like NLP is all over the place. But NLG, there is open standard for NLG as well, something called ACE, or rather CNL, Controlled Natural Language. It looks like human language, but it's machine readable. It's an open standard from W3C as well, I think. So there are some open implementations of that, but I didn't find a single component that does both of them. So we will probably end up doing either our own implementation or have to find two different services for that. And I think we should try to go two different services, pick the ones that does the best in one area, not just get a half-assed service that does half of each. Does that answer your question? Was it Monsef?
Yeah.
Okay. Here's a little, very tiny knowledge graph that I had to create. The information is probably a lot, not too meaningful. Most of it's probably not right. So this is what the actual semantic knowledge graph will look like eventually, and it's not. The edges are labeled. We don't see the labels here. The interface doesn't show the labels here. So it's a directed labeled cyclic graph. So you're going to have cycles, and you can have multiple edges connecting the nodes. So when I was talking about the triple subject, predicate, object, the subject and the objects are the nodes here, and the edge is a predicate. So an edge could be like some of the annotations that I use here. Supports is an edge. So Autodesk Live supports navigation, for example. So Live supports navigation. That's a triple. Supports is one of the edges. There are open ontologies for those kind of for the predicate. There are lots of open standard ontologies out there, but there is a serious lack of ontology for the 3D domain. There's some for ISC, the theme format, building information modeling information. The interoperable interchange file format for that is ISC. That's Autodesk standard. You can find it in Revit and whatever else, AutoCAD. So if you want to take Beam from one product, go to a completely different software, the standard way to serialize into IFC and then open it up in the other.
I thought IFC was an industry standard, though. I didn't.
It is not.
I thought it was an industry standard, not an Autodesk.
Oh, Autodesk initiated the whole thing, I think, like 25 years ago.
But it's a .org that's separate.
Yeah, now it is a separate entity that manages it. So yeah, and there is something called Building Smart. There's an organization that Autodesk started as well, and they're trying to do semantic BIM and semantic IFC. So there is something called IFC OWL, OWL is the semantic web language. So there is something called IFC OWL, and that's managed by Building Smart, the organization that was initiated by Autodesk. Before I go into the demo, I just want to note something that you see the Live Editor has a list of annotations there, which are the features that it supports, and the Live Viewer, I'm listing a few annotations, which are the features that it supports. It will be meaningful when I show the demo. And this is a max knowledge graph, and you can see it's an infinitesimal part of it, and it's also wrong. So because I have no idea how max works, I just needed something for the demo. So don't pay too much attention. Just this is what eventually a graph will look like, a semantic knowledge graph. So I think this is the end of the slides. I want to do the actual live demo that not even the judges had a privilege to witness. So, guys online, can you see the actual bot?
So
Yep.
is this
Yep.
this Autodesk bot thing, or is that what you guys wrote?
No, we wrote it.
Okay.
Oh, this is a WPF thing.
Okay.
So yeah, initially we wanted to just not do any interface, but because there's an interest from other people to showcase that we want a bot integrated into a product, for example. So at first we wanted a web interface only. We actually have a web interface somewhere. One of the teammates, King, he created a web interface for the bot. I don't know if it's up to date, but it's there. So we can ask what's Autodesk Live. It is going to Microsoft Cortana web service, coming back with NLP, the parsing natural language, and then I'm using that with the local graph database to query and find the information. The graph that I showed before, the information is there. That information is coming from the graph database. Even though it's not very granular, it's just a description, but you'll see some of the, you don't have a numpad.
Yeah. So can you type, now that it's given you that answer, can you type what is a visualization service? Or what is 3D visualization?
Yeah, I don't have that in my graph database, but you'll say you will not understand what's visualization service. So yeah, it will say it doesn't understand.
Okay.
Just a quick question. How robust is the system against like different sort of types of speech or mistakes and writing mistakes?
You can see that I did a typo. What?
Right. Yeah, I was impressed that it.
So this is as good as it gets. This is Watson or Cortana or Google. So we can't do better than that, I guess.
Okay.
I mean, we are talking about a powerhouse IBM Watson, which has like 9,000 cores or something like that, doing NLP. And I'm using Cortana. So yeah, typo and like you should be able to chat like you do in Facebook or
like.
Or
can you write like in gangster English and it will understand your question?
I don't know if it will answer that, but so the way it works. Okay, so let me talk a little bit about how the training. I have to train it. It's not free. This NLP thing is not free. So I have to find out what meaningful questions to train it with. So there's a web interface for Cortana and Watson. So you go there, log in, and you have to create your intents and entities so that the actual system can understand that. And you have to give sample questions. A couple of questions will do. So if I give you give the NLP service a question like, what's the weather like in Montreal? And I tag that as this is we're looking for weather information and the location is Montreal. That's enough as a training. And then you can ask, what's the weather like in Toronto? It will understand. You'll ask for weather information in Toronto. You don't have to train that. Just telling it that you're looking, Montreal is a city that you're interested in, that's enough because it has this whole big database of how to correlate that information. So the training part, it seems like it's hard work, but no, you just need 2 or 3 questions per context, I guess. So, so I had to create a bunch of intents and entities for Macs and Live and things like that. What features does Autodesk Live support? I don't know what it will give you.
Ask about our roadmap.
I'm not kidding. So except for the first line, don't fixate on the first line. The actual answer is coming from the graph. Each node is coming from each node of the graph database.
So does it know the context of this conversation? Because if you were really talking to someone, you wouldn't say which feature does Autodesk Live support. You'd say which features does it support.
Yeah, exactly. So let me just go back to the first question. It's not built in, but eventually if you ask what Autodesk Live, and then you can ask, tell me more. I am tricking it to understand it, but that's the goal. Yeah, it should understand. And some of the services like Cortana and Watson, they do provide you context as part of they have a bot interface as well, which does pretty much what I'm doing here manually. But yeah, the goal is to be able to tell for the bot to understand the context of it, and not only that, know the history of the user.
So I think the key here is to basically to get this functional in a tangible use case and in production. The key is to populate the database with contextualized content as much as possible.
Yes. So our team was contacted by GCSO, the Global Customer Support from TDG. They showed interest. They are doing something similar. They're actually in the process of implementing Watson to create a bot for customer support. And they saw our A2 video for the hackathon, and they showed interest in collaborating with us. And I had a meeting with them 2 days ago with two of the guys from the GCSO team. And Ian Hooper and Jenny and Corey from the Max team are also in collaboration with. We are taking this into. We're moving forward. We're taking steps to try to make it go further into and try to see if we can collaborate with the GCSO team as well, and probably maybe have a something for Max or some other product.
Did you have any learning experience or content developers with you in your team, or?
Yes. So yeah, Cooper is typing. But yeah, I think we had like 4 or 5 of them. We had 10 people altogether. 5 of us were developers, and the other 5 were UX content learning people. Most of them from the US. I will ask Ian to join in the conversation, or Jenny even though she was one of the judges, not one of the team members. But yeah, if you guys, anyone from the team, if they want to share their ideas or anything else they want to talk about, please. And I'm hoping that Ian will be able to provide some more information from his side. Yeah, so he's saying that all Manchester people were LA.
I had a question. Do you see a possibility? I think there was another hackathon project in which they were using a search bar for
that's one of the ones that's in the front panel. Yeah.
So I was wondering if this could be sort of integrated in the same way, like the Autodesk assistant can, in a sense, also assist you to do the tasks in your software. So you can say, hey, how can I extrude this? And then you say, well, do it.
Yeah, I was just thinking about that last night. Exactly the same thought.
Oh, great.
Good collaborate, I guess. Yeah.
Nice.
Yeah, that team was actually based in Toronto, and so we were working in the same room, and there was a lot of talk between us about the overlap in what we were doing. In this project, we had a lot of ideas around how this would be realized from a UX point of view, but we really didn't have a lot of time to go very far on that.
And I think kudos for you guys is that your thing does seem to work, whereas I'm not sure if they just made a video or.
Yeah, it was just a video. They were all designers, so yeah, it was really interesting because we were sort of pursuing the technical side of things, and they were looking more from the experience side. So yeah, it was pretty fun to talk to them.
I'm curious. Can you guys talk about the inception of this? How did you find out about your various interests and cross functional competencies? How did you find out, for instance? I mean, you have the UX perception and need for this. How did you find out about Mehdi's knowledge of this, technical knowledge of
I
that?
didn't. I didn't have much knowledge about that whole thing, semantic web, before. I just knew the concept, but not the technical details. So the actual seed of the idea came from the one of the research people from the Dreamcatcher team, and then Ian had a similar idea posted for the hackathon. Some other guys had similar ideas. I captured them all and said, let's do it together instead of competing against each other. And so,
I think it was really the idea connection. Like it was. Basically, Jenny O'Connor has been thinking about this in the context of Max for years, and she and I have been talking about it for a while as well. And then when this hackathon came up, and that was one of the areas of interest, computer as collaborator. I felt like we had to post something, and so when the idea went up on the idea connection, I guess other people who were interested in the same thing, like everyone just sort of saw the topics, and the hashtags were matching up to keyword searches, and there started to be a whole thread, and then Mehdi said, well, why don't we work on something together? So rather than all doing separate things.
Which validates idea connection, I guess.
It really did. It was a great example of that really working.
So if no one else has any other question, I guess we should give it over to the Hack Days showcase.
Yeah. So any more questions online? No? Okay. Well, thanks, Mehdi, Ian, and Jenny for this. It was really instructive and great. So, you want to go next?